Yeah. So we defined a few quantities: angular position, angular displacement, then angular velocity, which is rate of change of angular position. Omega is equal to d theta by dt. Units will be radians per second, but sometimes they just write it as per second, not an issue. Average angular velocity is delta theta by delta t. We solved one question based on that. And then we began relating linear variables to angular variables. Okay. We already knew this relation, L is equal to r theta. So L is the linear distance. Linear, by linear, I don't mean straight line. No, maybe I should not call it linear. Uh, L is the distance moved by the object along the circle. Okay. Yeah, I should not call it linear. It's not a straight line. Theta is the angle rotated by the position vector. Then L is related to theta as L is equal to r theta. This you all are aware already. By differentiating this, okay, because as an object moves along the circle, the angular position theta keeps changing. The distance L moved by it also keeps changing. So L and theta are variables. So if you differentiate this, you will get dl by dt is equal to r times of d theta by dt. dl by dt is nothing but the speed of the object. D theta by dt is nothing but angular speed of the object. So V is equal to r omega. Okay, let's continue from here. Now, what kind of circular motion are we discussing? Like before circular motion, we used one term.
Uniform circular motion.
Uniform circular motion. What does uniform circular motion mean? Or when do you call?
Observation.
Tell me.
It is moved uniformly.
When do you say it is moving uniformly? What should be constant for it? Good. Speed should be constant. Correct. So we now know that V is equal to r omega, where V is speed, omega is the angular speed. That's fine. Suppose the particle is here. If it is moving anti-clockwise, its velocity at that instant would be like this. Okay. At the next instant, you imagine the particle moving a little ahead along the circle. Its velocity vector rotates this way. So it is kind of rotating to the left. Speed is constant, so magnitude of velocity does not change. Direction of velocity keeps changing. And one of you quickly tell me, which component of acceleration, radial acceleration or tangential acceleration, changes direction of motion? Tangential is the component of acceleration parallel to velocity. Radial is the component of acceleration perpendicular to velocity. Which component changes the direction of motion of the object?
The radial.
Radial. Okay. We have discussed this many times. You have to keep these points in mind. Tangential acceleration is the component of acceleration parallel to velocity that changes speed. Radial acceleration is perpendicular to velocity, it changes direction. Now in uniform circular motion, the object must undergo change in direction, not change in speed. So in uniform circular motion, here for this question, the answer is radial acceleration. Therefore, in uniform circular motion, the object only has radial acceleration, no tangential acceleration. Okay. And okay, you all imagine this. Suppose there's an object moving slowly. Okay. Assume it is going in a straight line itself. Let's say there is a ball moving slowly. Will it be easy to change its direction compared to when it is moving fast? Or will it be difficult to change its direction when it is moving slow? So the question is, imagine two situations actually, not one. One situation in which a ball is moving slowly, another situation in which a ball is moving fast. Same ball. in which case will it be easier to change its direction? Easier in terms of force that you need to apply. Okay. Okay. Imagine a situation like this then. Suppose this is the floor. Imagine one ball, call it A, being dropped from here. Imagine another ball, call it B, being dropped from here. Okay, they're both dropped from rest. A will strike the ground and it will rebound like this. Okay, it may not go to the same height from where it was dropped, but it will rebound. So change in direction is happening. From downward, it changes to upward. B also strikes the ground and its direction reverses. From downward direction, it changes to upward direction. So both of them will undergo a change in direction. Now you tell me, in which case will there be a greater amount of force on the floor? Because the floor is what is changing their direction, right? In which case will there be a greater amount of force on the floor?
B, sir.
Second case, why? It's the same ball. Why should it experience more force in the second case?
Sir, because it is falling from more height.
If it falls from more height, what will be more for it? Because the ground doesn't care about height, no? Yeah. It strikes the ground with a greater velocity. Basically, by the time they reach the ground, B will be moving with a greater velocity. And if you want to change its direction, you will need to put more effort. You'll need to apply a greater amount of force. Okay. Similarly here, when an object moves in a circle, its direction of motion should keep changing. Okay. Direction of motion changes means velocity changes. We discussed this in the first time when we talked about circular motion itself. We talked about this. Velocity should change means acceleration should be there, and we just now discussed that there should be radial acceleration. Okay. Acceleration comes from force. So you just said that an object moving faster requires a greater amount of force to change its direction compared to an object moving slower. That is true for circular motion also, not just circular motion, in any case. Right? If you consider two similar objects, one of them moving faster than the other, the one moving faster will be more difficult to disturb. Means you'll need to put more force, means you need to give it more acceleration. Okay. So same thing happens in circular motion also. We just discussed that there must be radial acceleration, right? Radial acceleration will be perpendicular to velocity like this. At this position, it will be like this. There must be radial acceleration. And why is that radial? Why are we saying radial acceleration must be there? Because the direction has to keep changing. And the effort you need to put to change the direction of an object depends on the speed with which it is moving. So effort means force. The force required to change the direction of an object depends on the speed with which it is moving. That means the acceleration that is required to change the direction of an object should also depend on the speed with which it is moving. Okay. Therefore, we can conclude that radial acceleration depends on V, the speed with which the object is moving. Are you all convinced with this explanation or not? How much effort or force you need to put to change the direction of an object depends on how fast that object is moving. Okay, that is true. Right? You all must have observed this, no? From your daily experience, you tell me, is it easy to take a turn while moving slowly on a vehicle, or is it easy to take a turn while moving fast? What do you say?
Sir, while moving slowly.
While moving slow, it is easy. I mean, there's more guarantee that you will not slip. While moving fast, there are chances that the vehicle will slip. Okay. So there also, what is happening is, okay, one more question for all of you. Can you tell which force? Okay, if you are aware of it, you can tell. Can you tell which force helps us take turns on the road? I'll give you a hint also. We cannot turn easily on a slippery road, but on a rough road, it is easy to turn. So which force is helping us take the turn?
Frictional force.
Friction, correct. Okay, if the road is very smooth, it will be difficult to take a turn. Even if you're moving slow, it will be slippery. Okay, but if it is rough and there is sufficient amount of friction, then we can safely take a turn. Okay, now what was the discussion here? The discussion was about uh, greater speed requiring greater force. Now see, whether the vehicle is moving slow or fast, it is friction that helps us take the turn. Okay, but friction, which you'll learn in the next chapter in detail, has limits. Okay, two surfaces can only have a limited amount of friction between them. It cannot increase itself to infinity. There is a limit up to which friction can increase itself. So in case of slower moving vehicles, friction's limit will not be breached. But in faster moving vehicles, I mean, if it is moving faster, you will need more effort to make it turn. That means friction has to be greater, but friction has limits. If it is not sufficiently great enough, the vehicle will slip. Okay, so that is also an indirect explanation or indirect way to show you that faster moving objects require greater amount of force to change direction. Slow moving objects require less amount of force to change direction, provided they are identical. Okay, there are other factors also that matter, like mass and all. For now, same objects, I mean similar objects moving with different speeds, the one moving faster is difficult to turn. Okay, so radial acceleration depends on the speed with which an object is moving. Now imagine this situation, all of you. Suppose there are two identical objects again. You can think of this also as vehicle moving in two different situations. Let's say both are moving with equal speed. One has to take, or okay, call them as A and B. Object A has to deviate sharply and go this way, whereas object B only has to deviate a little and go this way. Tell me which is easier to bring about, or which of these requires less force from the external agent? From your everyday experience, you tell.
Yes, sir.
B. Okay, they are identical objects. They are moving in the same manner, but we need to deviate one of them more than the other. Whichever object has to be deviated more requires more effort. From everyday experience, we can tell this. Now observe, greater deviation means lesser radius of curvature of the path. I'm not saying this object is moving along a circle, but it's following a curved path here as it is getting deviated. That curved path has a radius. Fine. Here also, object B also follows a curved path. It's deviating, so it's following a curved path. That curved path has a much bigger radius. Less curvature means more radius of curvature. Okay, this does not look like a circle, but fine. So it has a greater radius, right? So if an object has to take a sharp turn, means if the radius of curvature of the path is small, it requires a greater amount of force compared to a similar object taking a gentle turn, right? And see, smaller radius of curvature requires greater amount of force, means smaller radius of curvature requires greater acceleration. Okay? So the radial acceleration, which is what changes the direction of motion of an object, it also depends on the radius of curvature. Smaller the radius of curvature, greater the radial acceleration, right? So these are the two factors on which the amount of radial acceleration depends. From everyday experience, we can tell this. Okay. Now there is an elaborate derivation how exactly AR depends on radial acceleration depends on speed and radius. Derivation I'll give you in the worksheet. You'll be able to do. I'll give you hints also. I'm telling you the result directly. An object moving with a speed v along a curve of radius r requires a radial acceleration of v square divided by r. Okay, as expected, greater the speed with which the object is moving, greater the radial acceleration. And r is in the denominator, means smaller the radius of curvature. Small radius of curvature means sharp turn. Okay, so smaller the radius of curvature, greater the amount of acceleration required. So this is the formula for radial acceleration. And in circular motion, we derived already that v is equal to r omega, right? So if you substitute that here, that makes radial acceleration equal to r omega whole square divided by r. That becomes r omega square. Okay, and let's go back to that diagram. Radial acceleration is perpendicular to velocity. Now velocity is along the tangent, not just in circular motion, in any kind of motion. That the velocity vector of an object is always tangential to the path along which it is moving. So velocity is along the tangent. Perpendicular direction means the radius. So radial acceleration by default points towards the center of the circle in which the object is moving. And since it is pointed towards the center, can any of you tell me if you know what is its name? Acceleration directed towards the center, what is it called? Okay, maybe you all didn't hear about it. It's called centripetal acceleration. Centripetal means something directed towards the center. There's an opposite also, centrifugal, a vector directed away from the center. We'll not talk about it now. So remember, radial acceleration in general is acceleration perpendicular to velocity. In case of circular motion, we call it centripetal acceleration. They are the same. Okay. Generally, you use the term radial acceleration. That can be used for circles, parabola, any curved path. You can use the term radial acceleration. You will call it centripetal acceleration when it comes to actual circular motion. Okay. Therefore, we can say that centripetal acceleration, I'm writing it as AC, is equal to v square by r, or r omega square. There won't be any tangential acceleration, right? Why is there no tangential acceleration? Because we are discussing the case of uniform circular motion where the speed is constant. So no question of tangential acceleration. All the acceleration will be radial acceleration itself. So this itself is the net acceleration in uniform circular motion. Okay. So let's quickly recollect what all definitions, not definitions, what all basic formulas we derived in this chapter. L is equal to r theta. This is one thing we can use to relate distance moved by the object to the angle rotated by its position vector. Next, differentiating this, we get v is equal to r omega. This relates speed to angular speed. Next, centripetal acceleration is equal to v square by r, or r omega square. This helps you find out the acceleration of the object, or if acceleration is given, you can find out speed or radius, something like that. Okay, let us make use of all these and solve problems. How centripetal acceleration becomes exactly v square by r? There is a very lengthy derivation for it. I'll send it to you in the form of a worksheet. Okay, Suppose the radius of the circle is 2 by pi meters and an object is initially here. Uniform circular motion, so we can't say it is starting from rest or anything. We have to give the speed with which it is moving. Let's say the object is moving along the circle with a speed of 10 meters per second. Okay, that's very, I mean, that's quite fast actually. 10 meters per second, let it be. Let's call this position as A. And okay, after some time, it will definitely reach some position B here. Let's say the angle between these two positions is 53 degrees. Or, okay, let's take 60. Fine. First, like as the object goes from A to B, derive how much is the centripetal acceleration at any instant. Next, time taken to go from A to B. Next, what is the angular velocity with which the object is moving? Next, what is its change in velocity as it goes from A to B? Definitely in a circular motion, velocity should keep changing, right? So at two different places, it'll have two different velocities. Find out the change in velocity. Calculate the displacement also. Do this, all of you, step by step. Yeah, Vanilla, tell me.
So should we take pi as 180 or 22 by 7, sir?
See, do you think the pi here is an angle? Is this an angle or do you think it's a number?
Number, sir.
It's a number. Okay. So pi as a number is always 22 by 7 only, or 3.1415 you can write. You never write it as 180. If it is pi
Okay, sir.
radians and you have to convert it to degrees, then only it is 180. Okay. And anyway, don't substitute any number for pi. Keep pi as it is. Keep pi in your answer also, not an issue.
Okay,
Those
sir.
don't waste time on calculation. Usually in exams also, if there is any term consisting pi, they'll give you pi in the options. Mostly it will be like that. Okay. And remember this, all of you, pi is approximately 3.1415. After that also there are, I mean, pi is known up to infinite, like you can keep writing pi up to infinite digits. Pi square is almost equal to 10. This you can use. If you are getting pi square in any expression, you can write it as 10. Okay. Aishwarya, how much is the centripetal acceleration needed here?
So 50 pi.
Okay, v square divided by r. V square is 100 divided by 2 pi becomes 50 pi meters per second square. Okay. See, the numerical value of centripetal acceleration is fixed. Why? Because speed is fixed and radius is fixed, then v square by r will always be the same. We are discussing uniform circular motion, but the direction keeps changing. Keep that in mind. Okay. At this moment, at position A, centripetal means towards the center, no radial. It will be like this. At position B, it will be like this. So if someone asks you the question, is centripetal acceleration of uniform circular motion constant? What will your answer be? In uniform circular motion, is centripetal acceleration constant?
Yes, sir.
Vanilla, how do you justify that? I just told you the direction is changing, so can you still call it constant?
It doesn't change, no, sir. It's the value.
Numerical value doesn't change, but the question was, is centripetal acceleration constant? By definition, acceleration, whether it is centripetal or radial, tangential, whatever, is a vector quantity. Okay. So if someone asks you, is centripetal acceleration constant? You have to think of it as a vector, whether it is constant or not. And vector includes magnitude as well as direction. So now what will your answer be? Is centripetal acceleration constant?
No, sir.
No. Okay. In magnitude, it is constant, but direction keeps changing. So on the whole, you will say it's not constant. If they particularly ask you, is the magnitude of centripetal acceleration constant in uniform circular motion? Then yes. Okay, I'm telling this to all of you. Direction will keep changing. Remember that. Next, time taken to go from A to B. Any answer? Okay. An object is going from one point to another point. You know the speed with which it is moving. You don't know the distance. That's fine. You need the time taken to go from that point to that point. And you also know that speed is constant, which is an advantage. If speed is constant, then distance is speed into time, or time is distance by speed. Okay? You can use those simple 6th class equations. So tell me, all of you, what else do we need to know to calculate the time? We know speed. What else do we need to know to calculate time taken to go from A to B?
Distance, sir.
Distance. Visualize that distance. See, you have to think like this. What is known, what is asked. What else do we need to know to go from what we know to what is asked? Okay, along the path, what other terms will be needed? You have to ask yourself. Okay, distance. Visualize the distance. Distance is from A to B and it's a curved distance like this. Is there any way to calculate this curved distance? Is
2
there
pi
any
r by 6, sir.
Okay, you want to divide the total circle into 6 parts and this is 1/6 of the circumference. Good, you can use that. Can be done. See, from 60 degrees, you were able to tell that. Suppose it was some other angle, 53 degrees. Then what will you do? Okay, your approach is, I mean, there's nothing wrong with your approach. You can use it. 60 degrees is 1/6 of the total angle 360 degrees. So distance also should be 1/6 of the total distance. Reasonable. But if the angle is something else, or let's say you are asked a general question that the angle is theta and you're asked and you have to find out that distance. What other ways are there? We know the radius. If radius is known and angle is known, what can you find? What can you calculate from it? Okay, I'll just write one term here, then it will strike. Now tell me how to calculate L. L is the length of the arc. How to calculate length of an arc?
R theta, sir.
That's all. L is equal to r theta. So the distance moved from A to B will simply be the radius 2 by pi multiplied with the angle. Can I write 60? Is this correct? Angle is 60 only. Can I write 60 there?
Sir, we should change it to radian.
Correct. L is equal to r theta is valid only when theta is in radians. Okay. 60 is in degrees here. How much is 60 degrees in radians? Okay.
5/3, sir.
Pi by 3, correct. Okay. 180 degrees is 1 radian. Sorry, is pi radians. Then 60 is 180 by 3. Then it should be pi by 3 radians. So we should not write 60 here. We should write pi by 3. Pi gets cancelled and L becomes 2 by 3 meters. That's the distance from A to B. Okay. Now you can calculate the time. Time is distance by speed. 2 by 3 divided by 10 becomes 2 by 30 seconds. Okay. See, first, when you are asked any question, no, you have to believe that you can do it. Fine. It will be from within what you studied. See, there's nothing new I used here. These are all known ideas. You just have to push yourself a little bit to think more about it. What else is needed? What am I missing? Think like that. Okay. And I understand you all are not comfortable with converting angles, and also I'll give you some extra practice based on that. Next, omega. Can any of you tell me how to calculate omega? Omega is angular velocity. There are very few things we discussed about angular velocity. One of them should work. Otherwise, I'll not ask you this question.
Sir, I have a doubt.
Yeah, tell me.
అక్కడ పై ఇంకా పై క్యాన్సిల్ అవ్వాలి కదా సార్.
Where?
L equal to R theta.
Pi and pi cancelled. That is how L became 2 by 3 meters. No? అంటే క్యాన్సిల్ అవ్వదు అంటున్నావా?
అంటే ఒక దగ్గర 180 ఇంకో దగ్గర 3.14 కదా సార్.
This pi is not okay. I understood your doubt. The pi here is not 180 anymore. Or like when we say 180 degrees is equal to pi radians, this pi, the numerical value of pi will not change. It is 3.14 only. It is 22 by 7 itself. Pi is always 3.14. If you convert it to degrees, then it becomes 180. Okay. So 60 degrees, the actual angle was 60 degrees. It becomes 3.14 by 3 radians. That's all. Pi here is 3.14 only. Pi radians changes to 180 degrees. Pi never becomes 180. Pi is always 3.14. Keep this in mind. Okay. One of you tell me how to calculate omega.
Sir, AC is equal to R omega square.
We don't know. Okay, we know AC. Fine. You want to use that R omega square. You can do it, but it's a little lengthy. Omega square is there. No, you'll again have to take square root. Can you tell an easier thing to do? What other relations did we learn involving omega?
V equal to R omega, sir.
V equal to R omega. So omega becomes V by R. That is easier. Okay. In this case, V is 10. R is 2 by pi. So 10 divided by 2 by pi becomes 5 pi. Pi goes to the numerator, becomes 5 pi radians per second. Okay. Now you can write it as 5 into 180 degrees per second. So radians, when it changes to degrees, pi becomes 180. You can't simply say pi is 180. If you put 180 here, it's like 5 into 180 is how much? 500 plus another 400, 900 radians per second it will become. That is wrong. Okay. If you are converting radians to degrees only, you should write pi as 180. Okay. Next, slightly tricky question. Change in velocity of the object. Do any of you have an answer to this? As it goes from A to B, we need to calculate the change in its velocity. Let us remove the unnecessary things. Generally, how is change in any quantity calculated? And this is a natural question that you should ask yourself. Change in velocity. So change mean, what does change mean in general? Tell me. How do you calculate change in position?
Sir, R final minus R initial.
Final value of the quantity minus initial value of the quantity. Do the same thing here. So change in velocity means final velocity minus initial velocity. That is what we need. Okay. Remember, velocity is a vector quantity. Both these are vectors. Initially, you know how you can see how the object was moving. The speed is 10 meters per second. The direction is given to you in the question. You know speed, you know direction. Then you can express the vector. So convert this to initial velocity. You can do it. Next thing you need to do is imagine the final velocity first. Finally, when it is at B, its speed will still be 10 meters per second itself, but it's pointed in some other direction now. Okay, take its components. What else can we do? You have to express it as a vector. Velocity is a vector quantity. So imagine an x-axis and a y-axis here, write the components. Similarly here also, at initial position also, this is the x-axis, this is the y-axis. Okay, one of you quickly tell me, how much is the initial velocity as a vector? You know its magnitude, you know its direction, express it in terms of I cap, j cap.
10 j cap, sir.
That's all. 10 in the positive y direction. So it will become 10 j cap meters per second. Good. Now that final velocity we need to express as a vector. Let us visualize it separately. This is the x-axis, the y-axis. The final velocity vector is tilted like this. Its magnitude is 10. To express it as a vector in terms of I cap, j cap, what else do you need to know? Is magnitude enough to tell the components?
You should know the angle with the horizontal.
Angle with the x-axis or the y-axis we need. Okay. Now you all use some geometry, your knowledge of geometry, and tell me what angle does that final velocity vector make with the x-axis? How much would this angle be? And with y-axis also, how much would the other angle be?
So 30 and 60.
Okay. Pawan, what do you say? How much is the angle with x-axis? How much is it with y-axis?
Sir, x-axis 40, y-axis 60.
Okay. Aishwarya, do you agree with that? Or you didn't get the angle?
Sir, I was not able to hear him clearly.
Now they said with x-axis it is 30 degrees, means the green one is 30 and the yellow one is 60.
So yes, sir.
Okay, fine. So that is correct only. See, the position vector rotated by 60 degrees from initial position to final position, the rotation is 60 degrees. Then the velocity vector will also rotate by 60 degrees because position vector and velocity vector are always perpendicular to each other. So if this position vector rotates by 60, automatically the other also will rotate by 60. Okay. And initially the velocity was in the y direction. So now from y-axis, it will have rotated 60 degrees. So with y-axis, it is 60, x-axis, it is 30. Pawan, tell me its components now. Let us visualize it here. Properly in terms of I cap, j cap, you tell the components. How much is this and how much is this?
Sir, -5 √3 I cap
Okay.
+5 √3 J cap.
Mala 5 √3 ఎందుకు సార్ రెండు సేమా angles are different, components will be different. Aishwarya, can you tell the y component?
So 5 J cap.
10 cos 60, it's only 5. Okay, and 5 √3 is to the left, so it becomes -5 √3 I cap. 5 is in the upward direction, so 5 j cap. Therefore, the final velocity is -5 √3 I cap plus 5 j cap meters per second. And now you can express the change in velocity, v final minus v initial. Subtract them, -5 √3 I cap plus 5 minus 10, so -5 j cap meters per second. Okay, is this calculation clear to all of you? Are you confident of calculating changes in velocities, expressing velocity first, then subtracting them to get the change in velocity? Can you do that or not? First thing to do is to visualize the velocity vector. And since you know the speed, you already know its magnitude. Then consider the angle and convert it into a vector in terms of I cap, j cap, that's all. Okay, we got change in velocity. Last thing to do is calculate the displacement. Okay, do this, all of you. As it goes from A to B, calculate its displacement. For reference, you can take x-axis, y-axis. Okay, assume this is the x direction. This is the y direction. By definition, what is displacement? By definition, what is displacement?
Change in position.
Change in position. So final position vector minus initial position vector is what you need to do. Write the final position and initial position as vectors. Aishwarya, how much is the initial position vector?
Sir, is it 2 by pi j cap?
Is it initially in the y direction? I don't think so. From where to where should the position vector be drawn? Position vector is from where to where? Okay, Pawan, can you tell the initial position vector?
Sir, 2 by pi I cap.
It is I cap. Position vector is from the center of the circle to the particle. So from center to particle, if you draw the vector, it's like this. Okay, the magnitude is 2 by pi meters, but it's in the positive I cap direction. Aishwarya, is it clear?
Sir, yes, sir.
So initial position is 2 by pi I cap. Next is the final position. Let us visualize the vector first. Again, position is from center to the particle. It's like this. We know its magnitude, 2 by pi, and you know what angle it makes. So you just need to express it as a vector. Have any of you done that? Okay, it's not a big deal. 2 by pi makes 60 degrees with the x-axis. So its x component will be 2 by pi cos 60. Cos 60 is 1 by 2, so it becomes 1 by pi I cap plus. With x-axis, if it is making 60 degrees, with y-axis, it will be making 30 degrees. Then the y component becomes 2 by pi cos 30. 2 by pi into root 3 by 2. That becomes root 3 by pi j cap. That's the final position. Subtract them, you will get the change in position. That is the displacement. Okay, not very difficult, can be done. Right. So you know the time it takes to go from A to B, you know the change in velocity and all those things. Can one of you tell me, with change in velocity and time, what can be calculated? What can we calculate from change in velocity and time interval? That means delta V and delta T. What can be calculated? Is there any formula relating these?
Sir, displacement.
How will you calculate displacement from change in velocity and time? If you could calculate displacement from that, then why did we do final position minus initial? We could have done that directly because we already derived change in velocity, no? Simply multiply with time, you could have gotten displacement. No. Or if you have another way to get displacement from it, let me know. Pawan, what was your thought? Like how did you think we can get displacement from delta V and delta T? Okay, it cannot be done. Okay. If you know velocity and it is constant, then displacement is velocity into time. But it's not change in velocity into time. Okay, you can't. Can anything be calculated using delta V and delta T?
Sir, differentiation just acceleration.
Differentiating, you can divide, no, that is enough. You can calculate average acceleration as change in velocity by change in time. Okay, so in this question, you can do that also. We got the change in velocity vector already. Minus 5 root 3 I cap minus 5 j cap. Divide that by the time taken. Time taken was how much? 2 by pi second, 2 by 30 seconds. So this can give you the average acceleration as well. Okay, let's discuss some more cases of uniform circular motion. Today we'll only discuss circular motion. Suppose the radius is r, okay, and particle is moving with a constant speed v. Calculate time taken to complete one circle or one round. Radius is given, the speed with which the object is moving along the circle is also given. How much time will it take to go once around the circle? Why is this taking so much time? You know the speed with which the object is moving. You are asked to calculate time. Pawan, what are you trying to do?
సార్ ఎల్ స్క్వేర్ స్టార్ తీటాలో అంటే తీటా స్క్వేర్ 2π పెట్టాలా?
You can do that. Full circle means theta is 2 pi. You can do that. Otherwise, you already
yes,
know
sir.
the length of a full circle, no? How much does it become? If you put theta as 2 pi, how much is it becoming?
సార్ ఎల్ స్క్వేర్ స్టార్ 2π.
2 pi r. 2 pi r circumference నీకు తెలీదా ఏంది? To go around the circle once, the distance that the object has to cover is the circumference of the circle. That's all. So time is distance by speed. Distance is 2 pi r. Divide that by v, speed. That's all. That's the time taken to complete one circle. Aishwarya, is this clear?
Hi.
Okay. Now tell me, if the object moves with constant speed, that means if it is uniform circular motion, will it always take the same time to do one round or not? Means will every round take the same amount of time or not? If the speed is constant and the circle is not changing, will every round take the same amount of time or not?
Yes.
It will. Okay. So uniform circular motion is an example. Okay. Tell me if you know the term for this. If any event or motion repeats after regular intervals of time, what do you call it? If any movement, event or motion repeats itself after regular intervals of time, what do you call it? Okay, fine. It's okay even if you don't know the term, that's fine. It's called periodic motion. Motion which repeats itself after regular intervals of time is called periodic motion. One example of that is Earth's rotation around its own axis. Every 24 hours, it repeats that motion, right? So rotation of Earth around its own axis is periodic. Revolution of Earth around the sun is also periodic. Every 365 days, it completes one round. Okay. So generally, motion which repeats itself after regular intervals of time is called periodic motion. Now tell me, is uniform circular motion periodic or not? Does it repeat after regular intervals of time, or does it repeat after unequal intervals of time? What do you say?
Sir, it's a periodic motion.
It is periodic. If the object continues with that speed, it will keep going around the circle, and every time it will do and every time it will do one round in the same time. Okay, so it will keep doing rounds in equal intervals of time, so it becomes periodic motion. So this time that it takes to complete one circle is called the time period of revolution. Fine. After every interval of 2 pi r by v, the object comes back to that place and starts the next round. Okay. Now we know v is equal to r omega. That means omega is equal to, or yeah, that means omega is equal to v by r. Therefore, this same time period t, which is equal to 2 pi r by v, that's the time taken to complete one circle, can be written as 2 pi. V by r is omega, then r by v will be 1 by omega. So you can write it as 2 pi by omega. So in terms of angular velocity also, you can tell the time period. And angular velocity by definition is d theta by dt, right? If it is constant, you can write it as delta theta by delta t also. To complete one circle, what is the angle that it needs to rotate? 2 pi. And how much time does it take? 2 pi r by v. Okay, or you can call this as time period. So you can say omega is equal to 2 pi divided by time period, or time period is equal to 2 pi by omega. You can derive it this way also based on the angle rotated in one circle. So this is another formula for time period of circular motion, uniform circular motion. Is this clear? Time taken to complete one circle. It's called the time period of uniform circular motion. You can write it as 2 pi r by v. You can write it as 2 pi by omega also. Okay. Let's quickly solve one more question based on circular motion. I'll make it a little simple. Let's say an object goes from this position to the diametrically opposite position. So from A, it goes to B. Constant velocity, of course. I mean, it's not velocity, constant speed. Let's just keep it as V. Let the radius be R itself. So first question. Calculate, okay, as it goes from A to B in that interval, calculate average acceleration of the object. This time I directly asked average acceleration. Last question, after finding out all these, I asked you to find out average acceleration by using delta V by delta T. This time the question is directly asked. It is understood that you have to find out these things first. What is the change in velocity and what is the time taken? Only then you can tell what is the average acceleration. Okay, so calculate that. Next, distance moved by the object, displacement of the object, and average velocity also. Do this quickly. All answers will be in terms of V and R and some numbers. quantities which are vectors have to be treated as vectors. So make use of I cap, j cap while solving. Okay. Any answer for change in velocity first? Because to express average acceleration, you need delta V, delta T. Any answer for delta V?
Sir, minus 2v I cap.
Correct. Okay. This initial velocity can be written as V I cap. And finally, the object, like when it is at B, it will be moving like this. That becomes minus V I cap. So final velocity minus initial velocity becomes minus 2V I cap. Correct. Next, Aishwarya, how much time does it take to go from A to B?
Sir, pi r by v.
Distance by speed. Half circle distance is pi r. Speed is v. So pi r by v. Divide them, you will get the average acceleration. And it becomes minus 2V I cap divided by time pi r by v. So that becomes minus 2V square by pi r I cap. That's the average acceleration. Pawan, is this clear?
Yes, sir.
Right. Next, distance covered. Any answer? There should be an answer. What is the answer for distance covered?
Sir, pi r.
That's all. Half circle distance pi r. Displacement.
2r.
Direction. Displacement is a vector quantity. I kept bar on it also.
Sir, 2r j cap.
Correct. Displacement is from initial position to final position. You can visualize it directly if you want. Okay. Or you can write final position, initial position and subtract them also. So it becomes 2r j cap. Okay, take the radius as capital R. Right. Next, average velocity. Any answer? And that also, there should be an answer. No, this is not negotiable. Pawan, what is the answer for average velocity?
Sir, 2v by pi.
Okay, how did you calculate that? And see, average velocity also will be a vector quantity. You know, you didn't say the direction. Okay, tell me how you calculate it first.
The total displacement by total time.
Total displacement by total time. Correct. Total displacement is 2r j cap divided by total time taken is pi r by v. So it goes to the numerator. 2v by pi j cap meters per second. That's the average velocity. Okay. Fine. These are the things that you need to know. See, in this chapter, we just introduce you the basic terms that we use in circular motion, and some basic calculations you should be able to do like these. Right. So I'll send you a worksheet Saturday, Sunday. Spend some time on this. I'll send you some questions based on the previous things also that we learned in this chapter. Monday onwards, we will start the next chapter, laws of motion. Okay. Laws of motion, right from the first class, all the concepts we are going to discuss are very important. Don't miss any class. Okay, you two generally don't miss any classes. The other students are missing. I'll inform them also. Fine then. Thank you all. We'll continue on Monday.